Welcome to qnawire.
Problem what we have is that 89.45 grams of CO2 were produced after the combustion of 49.95 grams of C4H10. We are told that this reaction occurred with an excess of oxygen, so it was turned into as much completion as possible, and we want to find the yield of the reaction. So first of all, we want to calculate the amount of mole of CO2. This is going to be equal to the mass of CO2 divided by the molecular weight of CO2. This is equal to 89.45 grams divided by 44 grams per mole, yielding 9.45 divided by 44, 2.033 mole. Next up, we want to calculate the amount of mole of C4H10. This is going to be the same procedure, mass divided by the molecular weight. In this case, we're going to have 49.95 grams divided by 58 grams per mole. Remember, each of the carbons has an atomic weight of 12 grams per mole. 12 times 4, 48, plus 10 of the hydrogens, 58. So the result over here is going to be equal to 0.8612 mole of C4H10. So now the information that we need is the chemical reaction. So our chemical reaction corresponds to C4H10 plus oxygen that is going to produce CO2 plus water. To balance this reaction, we're going to add four carbons onto the 4 into the CO2 due to the carbons to balance them out. The hydrogens need to be balanced with the hydrogens of our parent compound, so we need to add a 5 here. And finally, 4 times 2, 8, plus 5, 13. So 13 halves of O2. So this is going to be our balanced chemical reaction. You can see that we have 13 oxygens on the left. We're going to have 13 oxygens on the right, 10 hydrogens on each side, and 4 carbons on each side. So now we want to know the theoretical yield. So the theoretical amount of CO2 is going to be equal to the amount of mole that we had initially, of my limiting reagent, that is the hydrocarbon. Let me put it explicitly. Number of mole of C4H10 multiplied by the stoichiometric coefficients corresponding to this reaction. So we're going to have 1 mole of C4H10 is going to react to produce 4 mole of CO2. So we need to multiply by 4 our last result. This is going to give us a theoretical yield of 445 mole of CO2. To know the percent yield, this is going to be the amount of CO2 coming from the experiment divided by the amount of CO2 coming from the theoretical prediction times 100. This is equal to the experiment we got 2.033 divided by 3.445 mole times 100, giving a percent yield of 59.01%. So with this, it would be all. Thank you very much and have a good one.